Hi and welcome to this on maths prediction for the AQA Paper 2 Maths GCSE Higher Tier November 2020. Enjoy! Hi and welcome to this Paper 2 prediction from onmaths.com. If you haven't done the Paper 1, then you won't know that you can go and this link here and it will take you straight through to onmaths.com where you can try this paper out completely for free, and you can even sign up for free. It will save your scores and all that stuff. You can do that before you even watch this video, or what some people do is they like just to watch the video, understand how to do the questions and then test themselves afterwards. So what is the prediction? Well, prediction basically is our estimation of what comes up every single time with this exam board, what hasn't come up in ages and is long overdue to come up, and it's basically a guess. And it's an educated guess, but it is a guess, and that's why I say in every video, don't just do this and rely on it 100%. There will be a lot of topics that come up in this paper, but there also will be new topics that don't come up. So make sure you do all your revision, whether that's with onmaths.com or mathseffect.co.uk or a different website or a different revision guide or whatever it is. Make sure you do the work first. Otherwise, let's get started. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. Just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day, had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So, let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, factorise means put it into brackets. So looking at the first one, there's a t I can divide out of both of them, so I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket to check it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorise fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's two things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps. And the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2. I need to go 2 left. So 2 left. And let's have a think. How much up do we have to go? So 1 jump, 2, 3, 4. So 4 up. Now, the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, where it's gone 4 up. So it's just a 4 there. Now, here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now, be careful. Don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. These questions are just based on a few rules of indices. The first rule says that if you've got 2 powers with the same base, which these two do because they're both A, you add the powers. Now if you think about it, A squared is A times A to the power of 6 is A times A times A times A times A times A. So in total we're timesing A by itself 8 times. So it's A to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so the next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of -7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of -7 s to the power of 7. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number, and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be +6. On the previous one, we had a small number, 0.000084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question, because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9, times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimeters cubed, because every unit is in centimeters, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5. And I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise, I could do 5 times 180. Well, I can do 10 times 180, which is 1,800. Then halve it, which is going to be 900. And then half times 180, which is 90. So that's 990. So the answer is 990 grams. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59, so 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them, because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X, and I realise that it needs to be trigonometry, because this is a rectangle, that's a right angle, so I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse, so we're going to use sine, so SOH. So it's going to be sine 68 equals 27 over x. And I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68. And that gives me 29.1204. And I just do a few more decimal places than usual, because it's not an answer and you should never round your working out. If it's asking for 1 decimal place, I think 4 decimal places should be enough. But I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90, because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y, and I've got, so what have I got? I've got the adjacent here, so this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH, so cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. And it says it wants the answer to one decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now, multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do. So either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always. And 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now, 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So on your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now, I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to £917. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So they're two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the lengths by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles. And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two. And we're going to find out what we times 9 by to get to 36. So 36 over 9. And that's obviously going to be 4. Okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here, we're going from, sorry, if we go from small to big, we times it by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC, and that's going to be 15. So we know that it's going to be 15 here, for this bit, okay? But the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's to the nearest 5, so the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, the next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, to So what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. Okay, so for this question, understanding of the formula of a circle is critical. So formula of a circle is x squared plus y squared equals r squared. So it looks very, very similar to the equation given to us here. So if I rewrite the equation given to us, and instead of 4 I write 2 squared. Okay, and that's a perfect match for the equation of the circle. So we've got a circle with radius 2. So it's from the origin, which is here. Let's do this in red so it shows up. And it will pass through, it will have a radius of 2. Now, I don't have a compass, but when you're doing this, do it with a compass, and you're going to see how rubbish I am at drawing circles. That wasn't bad, although I think it's just going to get worse. It's probably the least pathetic circle I've drawn, but use a compass in the exam. Measure out the radius on one of the axes, and then just draw a circle, and that's 4 marks. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now the next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4, 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach which I'm going to use is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it X, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine X over, so this is sine X, this is X here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8, so it's going to be sine X equals 8 sine 110 over 12, and then what I'm going to do is inverse sine both sides. Scroll down a bit more. So X is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that X is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that Y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as Y, just to make it a bit easier. So Y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that Y is 31.2104 blah blah blah. Okay, so I've worked out what Y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. Where's A and B? A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got, say, 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. There are a few different ways of answering this question. I'm going to show you what I feel is the easiest technique, but if you've got a different technique you get the same answer, then stick with it. This question will all be about multipliers and understanding how to use them, but the difficulty in this question is we're finding out how long it will take to get to a certain point, which is a big twist in this question, and we're not given a quantity. Now, whenever you're not given a quantity, one method of being able to do it is by putting in your own quantity, and the easiest quantity to put in is the number 100. So I'm going to pretend that the population of the town at the start is 100. Now, this question, as I said, is all about multipliers, so we need to figure out what a decrease of 6.5% as a multiplier is. And to do multiplier, you start off with 100%, you do whatever the question's saying, so this time we're decreasing by 6.5%, and this will be on the calculator paper, so you might as well use your calculator to do 100 take away 6.5, and hopefully the answer is 93.5%. And to convert it into a multiplier, you just divide by 100. You're just converting it to a decimal, but the paper will call it a multiplier. That would be 0.935. So whenever I times something by 0.935, I've decreased it by 6.5%. Okay, so we've got 100. And what I want to do is figure out how many times I need to multiply it by 0.935. Okay, so there's a power here which we don't know yet, to get the answer that is less than 47% of it. Well, the reason I pick 100 as my quantity I've made up is because 100 is nice and easy, because 47% of 100 is 47. So we need it to be less than 47. Now, what I do on my calculator is I type in 100 and I times by 0.935 and I get the answer of 93.5. Now, what I'm going to do now, and that's one time, what I'm going to do now is press answer times 0.935. And what that will do is allow me to go through this same calculation as many times as I want by just pressing the equals button. So I'm going to press the equals button once and I get the answer of 87.42. So I've done twice in total so far, and I can leave a little tally mark here. I press it again and I get 81.7. Again, 76.4. Again, 71.4. Again, 66.8. Again, 62.4. So I'm getting closer. Again, 58.4. Again, 54.6. Again, 51. I'm getting close. Again, 47.7. So I'm getting very, very close, but I'm not quite there yet. And I press it one more time and I get 44.6. So in total, I've done it 12 times. Now, I'll always want to check that because my counting is not necessarily the best when under pressure. So what I'm going to do is I'm just going to do 100 times 0.935 to the power of 12 to check that I've got this right. So 100 times 0.935 to the power of 12, and I get 44.64. And I'm just going to check that that was the first time it went under. So I'm going to do to the power of 11, and what I can do is just scroll through my working out on the calculator and change the 12 to 11 and press equal, and that's 47.744, blah blah blah. Okay, and each of these are rounded. Okay, So it's going to take 12 years, because 11 years gets us close but not quite over the line. It's the 12th year that it dips below 47%. Now, as I said, there are different methods. You don't need to include the 100 as a made-up value. What you can do is just look at the multiplier and wait until the multiplier is 0.47 or below, below 0.47. And the multiplier would go down to 0.4464, blah, 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 blah. That's absolutely fine method. And there are other ways of doing divisions, which I'm not going to go into because you don't need to go that far. Because when you hit A level, there's a much, much better way of doing it, but we don't go through it at GCSE. If you wanted to look into it, it's to do with logarithms, but we won't go into that. Now, this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population, and then you capture a few more again. And then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. N, which is the population size, that's what we're trying to find out, it equals M. Now, M is the amount of things that you marked and then released. So on our example here, we marked 4. Times N. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here, it's 2. So let's apply this to the question. Let's try and work out what M is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, or some often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831. Okay, so this question looks quite simple, but actually it's going to take a bit of time to sort out. So first thing I'll do is do a little sketch. I'm going to do it up here. Since the y's are mainly negative, in fact are negative, both negative, I'm just going to show the bottom of the graph. So at point 7, we're at minus 17, which I'm going to say is here. It's a sketch, so it doesn't have to be perfect. And at point 19, we're at minus 11, which I'm going to say is here. Okay, this is called line AB. Now we're asked for the perpendicular bisector. Now perpendicular means it's going to hit that line at right angles. Bisector means it's going to cut it right down the middle. So I'm going to start off at the middle of the shape and draw a quick sketch there like that. Okay, I'm going to call, I'm I'm going to call this M here, and I'm going to call this line C, just so I can reference it in my working out, and it makes it a bit clearer. Now, there are two things I need to find out to find out the equation of point C. I need to find the gradient of point C, and I need to find the y-intercept. The gradient is going to be the first thing I'm going to have to find, and then I can work out what the y-intercept is, and then write the equation of line C. So, two things I need to work out for line AB is the gradient. So the gradient is going to be change in y over change in x. So the change in y is minus 11 take away minus 17, and the change in x is 19 take away 7. Okay, so we've got minus 11 and then effectively plus 17, which is 6, divided by 19 take away 7. Okay, 19 take away 7 is obviously 12, so 6 divided by 12, which is a half. So the gradient of that is going to be a half. Okay, next I need to find the midpoint, because we know that that's also a point on line C. Okay, so the midpoint is going to be the average of the x's, so 7 plus 19 over 2, and then the average of the y's, so minus 17 plus minus 11 over 2. So we're basically just finding the halfway points. Now, obviously 7 plus 19 is 26, divided by 2 is 13, but you might have just noticed that 13 is halfway between 7 and 19. Same with the others. Obviously, we could do the same thing. Halfway between the two of them is going to be minus 14. Okay. Now, you might be wondering, well, why did we find the gradient of line AB? Well, perpendiculars have a kind of weird connection where if you multiply both their gradients, it equals minus 1. Now, the way we use this is to convert a gradient to a perpendicular gradient. We do two things. We find the reciprocal of the gradient and we times it by minus 1. So to find the gradient of line C, what we're going to do is flip it. So the reciprocal of half is 2 and times it by minus 1. So it's going to be minus 2. Now, a way of checking that is if you multiply the two gradients together, you should equal minus 1, which a half times minus 2 is minus 1. So we've got the gradient. Now we know that a formula for the equation of line C is y equals mx plus c. We actually know the gradient and we know a point on that line, which was the midpoint of line AB. So we're going to feed in the coordinates. So it's minus 14. We know what the gradient is, minus 2. I'm going to put this in brackets, times the x coordinate, which was 13, plus c. And we just solve this to find out what c is. So minus 14 equals, and that's going to be minus 26 plus c. I'm going to add 26 both sides. And if this is on the calculator, then obviously always use your calculator to be sure. So it's going to be 12 equals c, or c equals 12. So therefore the equation is in the form y equals mx plus c. It's going to be y equals minus 2x plus 12. Okay, so this question is involving a probability tree diagram. And if we read the question, it says that the counter's not put back in the bag. Therefore, we know it's going to be conditional. Now, conditional means that the probability of the second event, so taking the second counter, depends on what you did the first time round. Okay, the way probability trees work is you start on the left hand side and you have an option. You can either go up if you pick blue or down if you pick red. Now, because you have to pick one of the options, the two options have to add up to 1. So if blue is 3 over 7, the bottom one must be 4 over 7. Has to be, because then it adds up to 7 over 7, which is 1. Now, if we picked a blue on our first counter, The probability of us picking a blue again is 2 over 6. So therefore the probability of us picking a red will be 4 over 6. Okay, now let's see where those numbers have come from. It says in the question that there are 3 blue counters and 4 red. Therefore the first probability of a blue being 3 over 7 is because there's 3 blue counters and there's 7 altogether. The second probability, so if I picked a blue on the first counter, went down, well, if I picked a blue again, to 2 over 6. That's because there's 2 blue counters and only 6 left altogether. So we need to know that to be able to fill out the bottom one. So if I picked a red on the first time round, what's the probability I'll pick a blue? Well, let's have a think. There are still 3 blue counters in there, but there are only 6 left altogether left in there because we've picked a red. So the probability of us picking a red, well, there were 4 before we picked one, but we've picked a red, so therefore there are 3 reds left and 6 left altogether. Now I'm deliberately not cancelling these down. I could cancel it down to a third, 2/3, half, half, but I'm just going to leave it as it is for now, just to make things simpler. Okay, question B says work out the probability that the 2 counters picked are different colours. So let's follow our routes along. I'm going to go up and then up, so blue and then blue, blue and then red, red and then blue, and you're always starting from this point here, and then red and then red. Now let's have a look. Blue and blue are not different colours, so we're not interested in that. Red and red are not different colours, but the middle two are. So what you do with probability trees is you start here and you collect all the fractions that you went past on your way, on your journey to the end. So we went past 3 over 7 and 4 over 6. Now the word and there is really important because and in probability means times, and you're always going to multiply them when you're going across a tree diagram. So I'm going to times the tops and times the bottoms. Again, I'm not going to bother cancelling down at this point. Okay, so the other option is I pick a red first and then a blue. So that is 4 over 7 and, mean times, 3 over 6. That's going to be 12 over 42. And normally these two will be the same. Okay, so just be prepared for that. Not always though. Okay, so we had 12 over 42 for the first option and 12 over 42 for the second option. But we can't pick both options, and this is the problem. We've got 2 probabilities, 2 answers. Well, we can't possibly have that. The word or comes into effect here. We either pick a blue and then a red, or a red and a blue. And the word or in probability means add. So all we need to do to finish this question is add the 2 options we had. So when you're going down here and you're collecting all the fractions you got, you just add them together. So we're going to add the tops together, which is 24 over 42. So it's half top and bottom, and let's cancel it down now. 12 over 21, and I think I can divide them both by 3, so it'd be 4 over 7. So my answer is 4 over 7. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer, and use a 2 here. Now you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now the beauty of these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angle triangle here, we have 2 of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimetres and 5 centimetres, and all of them in centimetres, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras. So we're going to square them, add them, and then square root it. And we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61. And we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Oops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11, and we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it x, equals opposite over adjacent. Tan x equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that x is 54.62438 blah blah blah. It says it wants it to 2 decimal places, so the answer I'm going to write is 54.62. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this, because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now, it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10 and the last one's 15. So when I've got the class width, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well, that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator, it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2. So can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. So that would be perfect. So I can go up in ones on the 5 squares. So it would be 0.2 here because they're 2 squares. 0.4, 0.6, 0.8, 1.0 or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high and it's 0 to 10. So we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20 and it's 0.1. So it'll be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one because it's only 1 square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one and then we finish that off. Excellent. Okay, So the next question says work out an estimate for the number of trees greater than 40 metres. So I want to draw a line up from 40 and we want it to go across here. So we're looking for an estimate for the amount that are in here. If you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6 because the total frequency for that bar is 6 and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.